Section 6.3.19-T with technology. Cars arrive at a certain restaurant's drive-thru at a rate of 0.2 cars per minute between the hours of 11 p.m. and 1 a.m. on Saturday evening. The restaurant begins an advertising blitz that touts its late-night service. After 1 week of advertising, the restaurant's officials count the number of cars, X, arriving at the restaurant's drive-thru between the hours of 12 midnight and 12:30 a.m. for 195 of its restaurants. The results are shown in the following table, and we're going to use the table to answer parts A through C to the right. So for part A, we want to construct a probability distribution for the random variable X, assuming it follows a Poisson process with lambda equal to 0.2 and t equal to 30. This is a probability distribution of X before the advertising. And remember that X is equal to 0, 1, 2, 3, all the way to 16. Well, the first thing we need to do before we do anything, okay, is to determine what is the mean of this particular event. We know that lambda is 0.2, and we got t to be 30 because 12 minus 1230 gives us 30. So in order to find the mean, we're going to take the value of 0.2, multiply it by 30 to get a mean of 6. So now we're going to use that mean in order to find our Poisson probabilities for each individual number of cars arriving. So we're going to go ahead and use this table here. So here's the table with the amount of cars arriving. Now notice 0 is not included, so we're going to have to include it when we open it up in StatCrunch. So we're going to open this up into StatCrunch. Okay, so let me go ahead and open that up here. And so then we're going to put 0 all the way down here. Okay, and so what we want to do is we want to then generate, okay, what are the probabilities, the Poisson probabilities. Now remember that our mean we found is 6. So we're going to go to Stat. Okay, now before we do that, we're going to title this new column the probability of X, because that's what we're going to find. Okay, so we're going to go to Stat, select Calculators, and then go all the way down to Poisson. Now remember, our mean is 6. Okay, so since our mean is 6, let's find the probability of 0. So we're going to let X equal 0. Okay, we're going to select Compute. Now rounding this to 4 decimal places gives you 0.0025. So the probability is 0.0025. Okay, and then we're going to change this to 1. Now let's find, then compute that. Now in addition to this, we're going to write it over here as well. We'll have 0.0025. Okay, next we're going to change this to 2, or 1, excuse me. And then we're going to go ahead and compute, and we get 0.0149. So 0.0149. Okay, and then over here, we're going to put in 0.0149. Okay, so now we're going to change this to exactly 2. And let's compute. So we get 0.0446. So we're going to put that over here, and then we can copy and paste in here. Okay, and then we're going to change this to exactly 3. So this gives us 0.0892. So we can copy in here, and then copy over here. And then let's open this up again, and we're going to go X is equal to 4. And this is going to be 0.1339 if we round it to 4 decimal places, 0.1339. And then let's copy that. And then let's put that over here. And then next, we're going to let this equal 5. Hit compute. 0.01606. Okay, so now you get the idea of putting our values in here. So I'm going to go ahead and do this, pause it, and then come back so you're able to see what we need to do next. Okay, so now we've generated all 16, well actually 17 values, and we put in our probabilities and they all check. Okay, so now the next thing that we want to do is the following. We want to be able to create a new column where it's designated as the restaurant. And so we want to take each probability and multiply it by the amount of restaurants that are between 12 and 12:30 a.m., which is for 195. So what we're going to do is we're going to select this part here. We're going to go to Data, and we're going to go to Compute, and then we're going to build an expression. So what we're going to do is when we build this expression, we're going to go ahead and contain this in parentheses. So I'm going to have my left parenthesis, and then we're going to take each probability, okay, and then we're going to multiply each of the probability by 195, okay, and then what we're going to do is then it's going to generate a new column. Okay, so we're going to select Compute, and so therefore we can say that this is going to represent R of the value of X. And so now what this represents is the number of restaurants that expect to have the amount of cars over here. So starting with 0 down at the very bottom, how many are expected to have the number of cars for 0? Well, that means that it's 0 because it is 0.48. And then the amount for 1 is 2.9, which is 3. Okay, and so putting in the rest, we can see that for the number of cars of 2, we get 9. For 3, it's 17. For 4, it's 26. For 5, it's 31. For 6, it's 31. For 7, it's 27, rounding it to up to 27. 8 is 20. 9 gives us 13. 10 gives us 8. 11 is 4. 12 is 2. 13 is 1. 14 is 0. 15 is 0. And 16 is 0. And therefore now we have all of our values in here for the number of restaurants that expect to have X cars. Now the next question says, compare the results with the number of arrivals after the advertising, and does it appear the advertising was effective, and why? Okay, so what we want to do is we want to find the observed total number of arrivals. Now in order to do that, to find the observed total number of arrivals, we're going to take the number X that we have and multiply by its frequency. So here we're going to build. So we're going to go Data, we're going to compute another expression. Okay, in this case, we're going to take the, in parentheses, left parenthesis, we're going to take the number of cars. Okay, and then we're going to add another left parenthesis and we're going to multiply it by its frequency. Okay, and then parenthesis, hit OK, and then select Compute. Okay, so we want to make sure that we put in the multiplication sign, which I didn't on that one. So let me go ahead and put in the multiplication sign, and then select OK, and then select Compute, and therefore there are our values. Now remember that this would be 0 times 0, so therefore this would give us 0. So what we want to do is we want to call this now the observed values. So we'll just call this observed, and we want to find the total of this column. So we're going to go to Stat, Summary Stats, and go to Column. And then we're going to go down to Observed, and then what we want to do is we want to find the sum of that column. So we're going to select Sum, select Compute, and it gives us 1,321. So let's go ahead and put that in here, 1,321. And so therefore, that is going to represent the observed total number of arrivals. Now what we want to do is we want to find the expected total number of arrivals. So now in order to find out what is the expected total number of arrivals, well, again, what we're going to do now is the following. Okay, now we are going to take the following. Now remember here that we generated these values here. So we had the R of X. So we're going to call this in the expected value. So this R of X, we rounded to 3 in our problem. So over here, we can see that we had 3. Okay, and then this was 9. Okay, this was 17, and then 26, 31, 31, 27, 20, and then 13, 8, 4, 2, 1, 0, 0, 0, and 0 was also 0. Now what I did is I wanted to make sure that these numbers that we rounded here, we got these values. So we want to make sure, because we want to multiply these numbers by X and then compare it, because this is the observed. And now we're going to build a new expression. So we're going to call it data. We're going to go to compute and select expression. Okay, and now in this case, what we're going to do is we're going to select the parenthesis, again, the X number of cars arriving, and then we're going to multiply that by, in this case, the one where we rounded it was VAR4, so we're going to select that column, and then we're going to put parentheses around that. Okay, and then we're going to select OK, and then we're going to compute. So now this gives us, this times 3 gives us 3. 2 times 9 gave us 18, and so on. And so now this is considered the expected. And so in order for us to find the total of this column, we're going to go to Stat, Summary Stats, and go to Column. And now we're going to select the expected, and then we're going to find the sum of that column. So let's find the sum, and that gives us 1,144. So 1,144 is the sum of that. And so now what we want to do is, now, was the advertising campaign effective? That means that, was it effective or not? So now we can say, because the observed total number of arrivals is greater than the expected number of arrivals, then we would say that this advertising campaign appears to be effective. So we're going to rule out A, we're going to rule out B, and we're going to say C, and so therefore there is our answer.